Thank you very much, Mr. Gazaf, for the very inspiring talk. Any questions are going to be answered at the very end of the session, so please note them down. So now we're moving on to our next presentation for today. It's a distinguished faculty presentation. In fact, it's our very own Dr. Mahmoud al-Hindi. Dr. Hindi is currently an associate professor at the Chemical and Petroleum Engineering Department. He actually joined AUB in 2009. He obtained his bachelor's and master's degree from the University of Leeds in the UK and a PhD from Imperial College. Dr. Hindi has over 16 years of industrial experience, which is a very valuable asset to our department. We'd like to welcome him all, and today he's going to be sharing with us his current research interest, which is about issues with pharmaceuticals in the environment. With that, I leave the floor to Dr. Hindi. Thank you.
I'm not sure if you can hear me very well. Can you hear me very well? You can't hear me. What are you doing, Manchester? This is really well. Can I take the microphone? So yes, don't worry about that. I don't want to waste people's time. The microphone? Okay, so the title is what are the issues related to pharmaceuticals and the environment? But before I start that, I was asked by email, discuss the highlights of your career and what are your achievements? It's a tough one. I have no idea where to start. I don't think I have many achievements. All I can tell you at the moment is that I spent 16 years in industry and I was dealing with all sorts of things related to water and wastewater. And if you sort of see some expressions there you don't understand, TSE for example, it's tertiary sewage effluent. The civil engineers probably will understand what I'm talking about, and some other chemical engineers. So basically, time was spent doing design, procurement, project management, and general management. Somehow, there are two people in this room, one of them sitting on the front row without any hints. They convinced me to come back to academia. Is that a good choice? I'm not sure. I can tell you in maybe 10 years' time when I retire. So let's move on, and we'll talk about other issues related to what I did in the real world later on. But before that, I think most of you should know that this is an RO, industrial scale. This actually was built in UAE, in Dubai. And you just take note of the scale of the pump and the tank and also of the RO system. All right, and we'll come back to it later on. So what are the research areas I'm currently conducting? Before I actually go into details of pharmaceuticals in the environment, I'd like to mention other areas of research. And before I even do that, I want to thank all of the collaborators that I've worked with. Were they faculty members? Were they students, graduate students? Were they people from outside? So the main research areas are desal, of course, this is what I know best, CO2 sequestration, optimization of process systems engineering, citizen science, which really is a very interesting subject, which we will not discuss today, we'll discuss some other time, and finally, pharmaceuticals in the environment. So what are the issues related to pharmaceuticals in the environment? There are several. The question, obviously, we are in a research institution. Is it an active area of research? Secondly, where have they been detected? Thirdly, what are the concentration levels? What are the most common ones? How do they get into the environment? What are the effects? And what do we really know? And finally, what are we actually doing about it here at AUB and from a local level as well? So the issue has been covered quite extensively in mainstream media. It sort of received the first attention way back in 2003. Then there was a major seminal report about drugs and water in September 2009, and so on and so forth. What about research area? Well, the first published paper was in 1945, and it dealt with the presence of hormones in water. And it was naturally occurring hormones that they discussed. Since then, there's been a tremendous increase in the number of publications. And this is from a paper by Dalton in 2016, one of the most highly cited authors on the subject matter. And you can see from the bottom axis, there are 14,000 publications, and that is until April 2015. And it's going at a tremendous rate. Why? Well, because one of the main reasons for that was the improvement in the detection capabilities of the instruments.
we can actually now measure up to the very low nanogram level. And based on that, people started going around the world and checking where they exist. And they discovered that they appear throughout the world, in water, grey water, surface water, and even in drinking water. And based on this, you'll see that 600 pharmaceuticals have been detected worldwide out of a possible 3,000. This is from a very recent paper by Derbouk et al. In 2016. And if you notice, the areas in the Middle East, there are very few studies done in our part of the world, which is really a shame, and we'll come back to that in a second. All right, so what are the main substances that have created the concern? There are 16 of them. And if you notice from the list up there, they range in pharmaceutical category from analgesics to antiseptics to antibiotics to also hormones, all sorts of hormones. How do they get there? Any ideas? No? All right, well, I'll tell you. There are several pathways, okay? And the pathways range from direct discharge, i.e. you guys take a pill of some sort, and your body can only metabolize a certain percentage of that drug. It ranges between 10% up to 95%, but most drugs are not metabolized correctly. And based on this, they'll go into the sewer, either via urine or via feces. Alternatively, they come from manufacturing facilities, or from the manure that's used as sludge, or from treated effluent. And therefore, based on this pathway, it can go into the soil, or it can go into the receiving water. This is also taken from Boxall et al. In 2012, which highlights where the pharmaceuticals go. So what happens when they get into the environment? What are the mechanisms and the processes that actually occur when they get into the environment? Well, they can either be photolyzed, or they can be hydrolyzed, or they can biodegrade. And some cases, in fact, when they biodegrade or transform, they transform into even more lethal products, which is a bit of a pain. Now, on rare occasions, and assuming, and I think the chemical engineers will know when I talk about the Henry's constant, for pharmaceuticals with certain Henry's constants, they can also volatilize, so they can evaporate. All right, what sort of concentrations are we talking about? The range of concentrations will vary depending upon the water source. So for example, if we have sewage treatment plants, then you will see that the concentration is in the high microgram up to the milligram level. So if you think about it, milligram is quite a substantial level. If you look at surface water, and by surface water we mean lakes, rivers, seawater, etc., the concentrations are lower, not that much lower, but they are still lower, the nanogram up to the microgram. The microgram level is more dominant in surface water. And finally, in drinking water, and this is where all of the hoopla is about, what are the concentrations? The concentrations are in the picogram and up to the nanogram level, but also the low nanogram level. So what's the big fuss? Why is it national news? Why are so many people interested in looking at this particular subject matter? Well, let's allow one of our students to come in. He's broken his leg. He's a Chelsea supporter. If there are any Chelsea supporters, okay. All right. So basically, what are the effects? Why are we studying all of this? We're studying this primarily for two well-documented and well-researched incidents that have affected the animal population throughout the world. One of them is in the UK, where male fish were being feminized. All right, and that happened in the late 1990s, early 2000s, and it was documented by two gentlemen, Sumter and Johnson, in 2008, where they discovered that the actual hormone, the artificial hormone that is used for the female contraceptive pill, 17-alpha-ethinyl estradiol, has resulted in this particular decimation, or in fact not decimation, and maybe they're happy changing sex, I don't know, but obviously they're not, okay? The other major decimation took place for vultures in India and Pakistan. The reason for that being that vultures fed on the carcasses of sheep and cattle, and these carcasses contained a drug called diclofenac, and diclofenac is an anti-inflammatory and it's an analgesic. And once these animals fed on the carcasses, they decided, we don't like life anymore, so bang, they go. All right, and 90% went. Now, how do we know that this was really the cause? And in environmental engineering and in impact assessment, you want to have a cause and effect. And a lot of people were arguing, no, it had nothing to do with diclofenac, it's nothing to do with it. When the actual prescription of diclofenac was banned in India, the populations went up again, all right? And there's been a lot of research, in fact, on the effects of these pharmaceuticals on all sorts of biodata. Right, the other thing that I think most of you should be aware of is the antimicrobial resistance. And what do we mean by antimicrobial resistance? We know that there are now certain types of bacteria that are resistant to all sorts of antibiotics, superbugs. And one of the reasons for the superbug is throwing a lot of the antibacterials into the water and into the wastewater system. Now, there are other reasons, of course, oversubscription, not using your pharmaceuticals correctly, etc., etc. Okay, so to use a very famous quote by a gentleman by the name of Ramsfeld, I think the younger generation here may not know what I'm talking about, but the older generation, I've seen a few smirks on the faces, all right? The known knowns and the unknown unknowns, which basically befuddles and confuses the whole issue. So what do we know and what do we not know? What we know is that there is no clear evidence affecting human health. That's United Nations Report 2013. There are a number of limited studies in terms of acute and chronic toxicities for individual pharmaceuticals on different biota. However, the fact that there have been very well documented incidents on the termination or the elimination or change in sex of a number of other species, apart from fish, the EU has decided to put 3 pharmaceuticals, well actually 1 pharmaceutical and 2 artificial hormones on a watch list. What does that mean? That means they're going to monitor the waters for a period of about 5 years. And based on a lot of studies and research done throughout the world, they will decide whether to put limits on them and therefore prevent people from discharging them directly into the environment. All right, one other area which people tend to sort of not cover a lot, and unfortunately we have some of it in Lebanon, and that's the issue of the production of wastewater from pharmaceutical industries. There's no regulation whatsoever on that, and it really is a cocktail of pharmaceuticals, and that cocktail of pharmaceuticals in combination with other contaminants will lead to all sorts of synergistic effects that could be pretty lethal. Okay, so what are the research questions that we're actually dealing with here at AUB? And there are several, and let's just summarize them very, very quickly. What are they? Do we know what they are? If we do, there are more than 3,000 pharmaceuticals across the world that are being sold. In Lebanon, when we gathered the data, we found there are 1,500. We also found that the amount of pharmaceuticals per capita in Lebanon is amongst the highest in the world. So obviously there is a problem, all right? Can we, from this list of pharmaceuticals, generate a priority? Why do we say it's a priority? Because if we want to test the water, each test would cost us a huge amount of money because we're using really very sophisticated equipment, LC, MS, and that's not very easy to use and it's very expensive to operate. In fact, we have 2 at AUB. One in the environmental lab and now one in the environmental engineering lab, which was purchased 2 years ago and is still not yet 100% operational. So we can't really do that research here as yet, but we're hoping to in the future. What we're doing right now is actually we're taking samples and we're sending them overseas. So that's one way around it. So how are they disposed of in our part of the world? And finally, and using the idea of the end-of-pipe technologies, can we get rid of them? By using simple techniques like adsorption on activated carbon generated from biowaste, or using simple technologies like solar stills, or shall we go for the more sophisticated, more complicated approaches, and that is using membranes or a combination or a hybrid system of the 2. And I think from an environmental point of view, it's always best to eliminate at source as opposed to eliminate downstream. So let's take them one by one. In the MENA region, we said there are a few limited numbers. In fact, there is one in Lebanon. And it was done by the geology department, but in collaboration with a German institution. And they only looked at one pharmaceutical, and that's carbamazepine, which is basically an anti-epileptic drug, which is really, really a bad drug, but it doesn't have a lot of effect on the environment, but it does not disintegrate. It can stay for generations. All right, I have a feeling Sabla is looking at me saying, yalla, 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 2 minutes. Okay, so I'll try and rush through this. So what we did is we did a priority study, and we, from the list of 89 pharmaceuticals that were what we would call high in terms of sales and figures and so on, we generated a priority list of 26. And these, as you can see, some are commonly found in other parts of the world, but some are quite unique to our part of the world, because as I'm sure you know, pharmaceutical prescription varies from one place to the other. We also looked at what happens to the pharmaceutical waste that you guys at home dispose of. How do you dispose of it? And we found that the vast majority of people in Beirut, they actually throw it directly, whether it's liquid or solid, into the solid waste stream. And that's 73% of the solid waste constituents in terms of pharmaceuticals. The other 13% would flush it down the toilet. The others, there are all sorts of things. Some people said they swap pharmaceuticals. Some people said they give away pharmaceuticals. And, but the vast majority basically throw it in the solid waste stream. So how can we stop this? And there are several schemes that we can use. One of them is a take-back program, waste collection, and I think the most important thing in Lebanon is reduce our self-medication. We rely on that a lot. Removal. Okay, we've now looked at 3 ways of removing. One of them is the simple solar still. We examined 5 pharmaceuticals and we discovered that in fact 1 directly transforms to the product water. So even at relatively high temperatures, you will have evaporation taking place of so-called stable compounds. But the vast majority did not transform. What is more dangerous, in fact, what we discovered was that the degradation products of these 5 pharmaceuticals that were supposed to be stable, when they were photolyzed, they were transferred into the product water. One other area of research that, in fact, one of the earliest MSc students at the Chemical Engineering Department did the work on, Reem, she looked at the removal of carbamazepine and other pharmaceuticals using activated carbon derived from date pits and also from olive stones, and this work was done in collaboration with quite a few people. And finally, in terms of removal, what we're looking at membranes. If you remember, the size of the membranes here and the size of the membranes before, we're talking about scale. The scale is tiny, all right? But it has its own challenges. Even on that tiny scale, we had some challenges, but in the end, with the help of Hadi, sitting over there at the back, quietly, we managed to resolve all of these issues. All right, I'd like to, not quite end, but there's another slide here. I think people who I've taught know that I like to sort of اتفلسف عليهم كتير زيادة عن اللزوم. So basically, I'm going to finish with a quote from a very famous environmentalist, one of the earliest environmentalists, Rachel Carson, who wrote a very famous book called The Silent Spring, where she says, in an age when man has forgotten his origins and is blind even to his most essential needs for survival, water, along with other resources, has become the victim of his indifference. And finally, the list of collaborators. And I really have to apologize here for the undergraduate students. And they really have been absolutely essential in this research because the slide did not contain their names. So for my collaborators, thank you all very much, and thank you for listening.